As far as the review goes, a few things we've been doing with polynomials. One of them is just making sure that they're in standard form, which again is your largest degree or your largest exponent term to least. And then name the degree of the polynomial. In other words, what's the exponent you see? Now sometimes they'll already be in order for you. Yes. For instance, in this case, this is already in standard form. Because if I look, I notice biggest exponent down to least. Nothing too bad. But then it also tells me I have to name the degree, which is always just going to be whatever the largest exponent is that I happen to see. So you kind of see why it's important that you want to have things in order, because otherwise that can get a little complex. When I go to the next one, not quite as lucky. 3, 5, oh, they're not in order. So I go from my biggest, and I just keep working my way down with my exponents until I get to the number at the end. Once I've got that, look for that biggest one at the beginning. And I'm set. Now this is the one that gets a little more interesting. Right in standard form, there's only one term, Harty. That's already in standard form. Okay. What's the degree of a plain old number? Because there's no variable on there to count. What would my degree be for just a number? Close.
-1.
Nope. Let's think about it this way for a second. We're like, okay, 5, 4, 3. If I have just a variable here, it's 1. What would come next for the one without a variable at all? What comes after 1? 1, 2, the other way. Okay. Any constant term, any term that doesn't have a variable of any sort has a degree of 0. So if the only term you have is a constant, that would be its degree. So that's kind of our, I guess we'd call it our trick question in that section, is what we'd be looking at there. Here we're just going to get a little work with simplifying and occasionally some distributing right in standard form. In other words, biggest exponent to least. So I notice with the plus, I'm not going to have a lot that I have to think about that way as far as changing signs, but I am going to need to put like terms together. So little detailed things like I owe somebody $5. I pay him 3 back. I still owe him 2. Notice I didn't touch the exponents. And we're going to work our way down. Let's see, I started with 4 3's coming next. Got 5, I got 8 more. 13, don't touch the exponent. We're adding and subtracting. And then I just got the 8m squared on the end. Okay. That's my simplifying, and it's in standard form because it goes from the biggest exponent, or the biggest degree, down to the least. So the ones with add aren't quite so bad, because really it's just a big game of combine like terms. Just got to watch the signs. And surprisingly enough, this stuff does come in handy, and here it could come in handy in geometry when you're trying to get some like terms. Maybe you're finding the perimeter of a triangle or finding the area or the volume, being able to work with those like terms. But the tricky part in this section comes when we get the old negative working, because that minus means that negative is going to distribute all the way through here. So it doesn't touch anything at the start, but it certainly does change every single sign that I see in the set of parentheses after it. Once I'm sure I got all my distributing done, all my signs changed, now I'm going to go back like I did on the other ones. Start with the terms that have the biggest exponents, and start combining them. But again, combine doesn't always mean add. Sometimes there's a minus in there, so I got to subtract. Got 8, I lose 5 of them. I've only got 3. With my x's. Again, be cautious. $6 in the hole. Ooh, another $7 in the hole. It's not going to get better, it's going to get worse. I squared, and then my last one are these two x terms. And again, they're not opposites. I owe somebody $5, I borrow 5 more, now I owe 10. Greatest to least on my exponents, I'm good. So really, this is just kind of a war of attrition here to see if I can stay patient enough to actually make this work. Last one, I'm fortunate, they're all pluses, no sign changes. So I start looking for the biggest exponent terms. Remember, there's a 1 in front of that other b to the 4th. So 4b to the 4th. I don't see any other b to the 3rds except that one. Let's see, b, yes, yes. Have $2. Ooh, borrow 4. 2 in the hole. And then my numbers 2 minus 7. Be at $5 in the hole, but then I find $6 in my pocket. I'm $1 ahead. So again, that section, bless you, is more to just work with, can you stay patient long enough to be able to fight through to the end? Products, we talked about this before, is having choices. I can distribute the old-fashioned way, just kind of using the arrow here. Remember, I'm multiplying. So if I multiply, 8 times 6 is 48 with my x. 8 times negative 4, again, I got to watch the sign. This has x, this doesn't. I'm done. So whenever I do that multiplying, we're always multiplying the coefficients, but we're adding exponents now. So I got end of the first and end of the first. I add them up. 5 times 5, bless you, it's like catching. And then I add the n, and again, I know they both have n's, but this is n squared and this is n. Again, it's as far as I can go. So you're like, okay, this stuff's not too terrible so far. When I distribute, I'm going to remember that a's got an exponent of 1. I'm going to multiply that out. 2 plus 1 gives me 3. 3 times 8 is 24, a squared. And that's as far as I can go. So I guess the biggest thing with these tends to be, don't overcomplicate things. Just multiply the coefficients, add the exponents. And I know the notes for these are still available over in the tray, because I checked this morning in the folders, I mean. 4 times 3 is 12. 1 plus 1 on my exponents is 2. 4 times 7 is 28. And I'm good and ready to go. One of the other things is we kind of blended equations back into all of this. So again, if on either side of the equals I have terms that are alike, I'm going to go ahead and combine those first. Now notice I didn't do anything with the exponents. I'm not multiplying here. My whole job is to isolate my variable term once, of course, I have the like terms put together. Now, what's my last step here on 12? Should I add 3 to both sides? Because I see a negative 3. Or is there an idea that it would be better than this? Am I subtracting 3 from k right there? Okay, right, I'm multiplying by -3, so I need to divide, because that's one of the things I've seen happen before too. And again, simple things. Negative divided by negative is positive. So there's lots of little detail stuff that can get me if I'm not careful. Combine my like terms. Go ahead and minus my 1 and get 0. It's not undefined, it's not impossible, it's just 0. And then finally, I can't do 5 plus 8 first. Whenever the parentheses there, the parentheses take priority over everything. 8 times -3 is -24a. 8 times -7 is -56. And then I have to look for my like terms, which I find. So let me rewrite this. 5 minus 56 is -51. If I need the calculator for that, that's not a big deal. But once I do that, getting that a isolated becomes my priority. And similar to what we did back in 12, now I just got to divide, and I think this is going to come out nice. Yes, yes it is. And I get my equation. And then our last group, again, I'll do one of each of these at the start each way, because we've talked about a couple of ways we can do this. When we FOIL, old way of doing it, we just would use kind of lines to connect the parts we're multiplying. 3 times 5, again, product, we're multiplying. And then I'd add the exponents. So k times k is k squared. And then I'd do my outer. 3k times -1 is -3k. Then I do my inner. 3 times 5 is 15, and I have a k there. And then 3 times -1 is -3. And again, if I do it right, that little dude's face shows up with my foiling. And the only thing I'll have left to do is to combine the terms that are alike. Watch your signs. -3 plus 15, so it's like 15 minus 3. And I'm set. Now some of you, just the idea of drawing those lines might get confusing, and it can happen. So if that's something and you're more visual, and you like to be organized because you tend to get yourself in trouble otherwise, your other option, and if you like this, you can keep doing it, I'm not telling you have to do it this way, is you can do a box on these. Same exact format, it's just a different way of looking at it. I still multiply my coefficients, and I still add my exponents. This just lets me see each thing I do, so I only do it once. 8 times 3 is 24. 6 times 3 is 18. So once I have that set, I just start in the upper right corner, and then I find my like terms as I go. And remember, once the box is filled, we multiply it to fill it, we're just going to be adding after that. So no messing with the variables anymore. And I can get to the solution that way. So these can all work in different ways. Now I'm going to skip past 17 here for a minute. Wouldn't hurt for me to leave you a couple on your own here. But when I get up to something like 18, again, This is all going to be dependent on how you want to do it. So I'm going to do 18 and 19 two different ways and let you pick how you want to go. If you like the distributive way, you could distribute and go piece by piece. Say, okay, so 7 times 3 is 21. Add my exponents. And then I do the 7 times the negative 4. Add my exponents. Then I do the 7 times the 4. Get that. But then I've still got to go through with that 6 and do it all again. So maybe I do it along the bottom here. So 6 times 3 would be 18. There's my x squared. And then I'd go to here. 6 times negative 4 is negative 24. And then 6 times positive 4 is positive 24. And I go back and combine my like terms at the end. So I go, okay, I only see one thing that's got to the third, so I'll write that first. There's my x squareds. Watch the sign in front. I owe somebody $28. I pay them 18 back. I'm going to owe them less. Now I only owe them 10. Don't messing with the exponents. 28 minus 24 is 4. And I get it into standard form that way. But I do have to finish that. I can't just distribute and think I'm done. What if that confuses me just looking at all those different places that I've got arrows going back and forth? Well, here's my other option. I also, like we did before, can do a box because the boxes can change size and adjust to whatever size I need them to be. So if I want to go that way, I can make a 2 by 3 box. Same concept's going to go along, but I'm going to organize my like terms a little bit easier. So for instance here, multiply my coefficients, add my exponents. Okay. Multiplying to fill. 2 times negative 6 is negative 12. 1 plus 1 is 2. 2 times negative 4 is negative 8. I don't have to put the 1 exponent on my end, but I could. 8 times negative 6 is negative 48. Don't forget about my variable term. Negative times negative is positive 36. And negative 6 times negative 4 is 24. And the only thing then I'd have left to do is to combine like terms. But here's the thing I like about this particular format. The upper left-hand corner is always going to be where my largest degree is. And then as I move down, each diagonal is going to have my like terms in it. 36 minus 8. And then the 24 on the end. So I'm going to leave you with 17 and 20 to do on your own. And then again, use the rest of the time to work on the current homework check, because that way when we get into Unit 9, you're going to have everything ready and raring to go already. So that's all that we're going to be doing on this.